Spend a moment and just take a look all around you. People's dogs and plants, everything it constantly moves. Even still objects like buildings or lamp in your room. They're still in motion because our planet's always moving. Speed's the distance an object moves in time, like the speedometer when your car drives. Meters per second is the answer, the standard for the measurement equation. Every speed equals distance over time, the scalar. Magnitude no measure of direction, instantaneous. Speed is the speed of an object at a specific moment in time, and it may speed up a slow measured in meters per second. Speed's only scalar, it doesn't tell us which way we drive. Calculated by measured distance divided by time. Like if you drove to your grandma's house just to say hi, you take the meters divided by the full time to drive.
Speed is distance over time. Speed is distance over time. Speed is distance over time. Distance over time. Speed over time. Speed distance over time. Speed over time. Distance over.
Hello, young scholar. Welcome to another exciting, interesting, fascinating class in mathematics. Remember, this is Mr. Gabriel Renan class, your teacher in mathematics. Today we are going to be taking a very interesting topic which I know you will love a lot, and the topic is average speed. When we hear about average speed, when we hear about speed, what comes to our mind is that how fast an object can be. Well, it's quite right, but in mathematics or in science, it goes beyond how fast an object can be. An average speed talks about how we could calculate the movement of a car per unit time. That is, if the car was able to cover a particular distance, how fast it was able to cover the particular distance per unit time. Now this will make me define average speed for you as the distance an object moves per unit time. The distance an object moves per unit time. This means that average speed is not a uniform rate, in the sense that a car cannot just start a journey with a particular speed and end that journey with the same speed. Is not possible, especially in our road around us. For example, if my father's car is taking me to school, and on the express road my father decides to increase the speed, but what if he get to a place where there's a pothole? It's so funny. If he continue with such a speed, it therefore means there's going to be an accident. So I will know that that is will be wise. I have to reduce the speed. Therefore means a car cannot move a uniform speed. So what we do in mathematics is to calculate the average speed the car moves at a particular time. So therefore, the formula for average speed is going to be summarized using a triangle. In this triangle, you can see that D is on top, S and T are below. D stands for distance, S stands for speed, and T stands for time. So when you are looking for distance, you can use your N to cover the D, and what you're having is S and T, that is speed times time. When you're looking for time, you can use your hand to cover the T. So what you have is D over S, which is distance over speed. And when you are looking for speed, you can cover the S, and what you have is distance over time. So with this triangle, I think you can remember the formula for speed, and you can have the ability to use any of the parameters to solve any mathematical question on speed. Now we move on to tell you that speed is always in kilometer per hour or meter per second. So we are either going to be using kilometer per hour or meter per second. Okay, so anytime you have kilometer, the time must be in hour. Anytime you have minutes, the time must be in seconds. So we're going to be solving with these parameters. Another thing we need to know is that distance is in kilometer or meters, while time, as we know, is either in hour, minute, or seconds. Now, you're going to be solving some worked examples. In this example, we have a question that says a cyclist traveled 4 kilometers in 20 minutes. A cyclist traveled 4 kilometers in 20 minutes. A. At what speed did he cycle? That is the first question. You're going to be having a variety of questions to solve using number 1 as a case study. Now, at what speed did he cycle? Now, the first thing we need to know is that the distance is in kilometers. Remember, I told you that distance is always in kilometers. Therefore, this parameter carrying kilometer is the distance. So, distance is equals to 4 kilometers. And the parameter carrying minutes, which is 20, is time. Because I told you that time is always in either hour, minutes, or seconds. So, now remember I told you that when you are looking for average speed, when we have kilometer, our time must be in hour. So we cannot work with 20 minutes. We have to convert 20 minutes to hour. And remember that 60 minutes make 1 hour. So in order for us to convert minutes to hour, we have to divide by 60. So while dividing, 0 cancels 0. What do we have? Remaining 2 over 6. Now reducing to lowest term, 2 can divide the numerator and the denominator. 2 divide 2 and 2 divide 6. That will give us 1 over 3. Okay, now we have 1 over 3 hour as our time now. So how do we look for speed? What is the formula for speed? Speed is equal to distance over time taken. So fixing the formula, remember our triangle that reminds us of the formula. When you're looking for speed, we have distance over time. So when you put this into the formula, you ask speed. You're looking for speed, so you can represent speed with s, which is an unknown, is equals to 4, which is our distance, over time. Remember that our time is 1 over 3. So you can place it 1 over 3. Our unknown is the speed, because we are looking for speed. Now we have s is equals to 4 divided by 1 over 3. Why do I say s divided equals to 4 divided by 1 over 3? Now the division you have 4 over 1 over 3. That over also means divide. So I can also say 4 divided by 1 over 3. And in mathematics, we cannot use division to work when we're having fractions separated by a division. So what we do is to invert. And by inversion, when you are inverting, the fraction after the division sign turns upside down. So the denominator goes to the numerator and the numerator comes to the denominator. And the division changes to multiplication. So we now have s equal to 4 times 3 over 1. Because the 3, which is the denominator, comes up while the 1 goes down. 3 over 1 is the same thing as 3. So what do we have? S is equals to 12 kilometers per hour. You can see, very simple and very easy to understand. Now we're going to be solving other questions using number 1 as a case study. Now remember that the speed we've gotten is 12 kilometers per hour. The next question is that how many kilometers could he travel in 1 over 2 hours at this speed? That how many kilometers can the cyclist travel in 1.5 hours at this speed. Remember, the speed we got was 12 km per hour from question A. Now, the parameter that carry R is the time. So we have 1.5 hours. Now, in mathematics, we cannot work with mixed number, so we have to change this mixed number to improper fraction. So 2 times 1, which is 2, the denominator times the whole number. 2 times 1 is 1, multiplied by the numerator, which is 1. So 2 times 1 is 2, plus 1, the numerator is 3, over the denominator, which is 3 over 2. Remember how we change improper fraction from mixed fractions. Now the next thing we need to do is to look for what we are looking for. Now what we are looking for here is the distance. Now from your triangle, if you cover your distance, you have speed and time in the same line. So it means distance equal to speed times time. Now since we are looking for distance, we can use an unknown to represent distance, which is s. So I can say s is equals to my speed, which is 12, times 3 over 2. Okay. Now in mathematics, what do? I can cross divide. 2 can divide 12. 2 divide 2 is 1. 2 divide 12 is 6. So what do I have? S equals to 6 times 3 is how many? 18 kilometers. Very simple. 18 kilometers. Now we're going to be solving another question. And this question says, please get your writing materials right. If you are not be writing, you can do well to go over the lesson and write all important points. The last question there says, how long would it take to travel 7 kilometers at this speed? Remember, the speed we got was 12. So how long would it take to travel 7 kilometers at this speed? Now the speed was 12 kilometers per hour. Now the parameter carrying 7 is the distance, because we have kilometer there. Now how long means how much time. So you're looking for time. And from our triangle, when you close your T, you're going to be having time is equal to distance over speed. Now our time is equal to 7 over, what is our speed? 12. So time is equal to 7 over 12 not kilometers but hours, because we are looking for time. So and time is in hours. So that is how we can solve any question on average speed. Depending on the parameters you are looking for, just use your triangle box to get your formula, and you are good to go by solving any mathematical question that comes your way. Please, I want you to go over this lesson meticulously. Write down important steps. Take note of the formulas. Thereafter, you have your interactive assessment to attempt, and then you have your quiz as well to attempt. Please, for your interactive assessment, you must play your fun game. You must have a score before you can proceed. And for your quiz, the same thing. I wish you success, and until we meet again in our next class, bye for now.